Hey guys, long time no see. Welcome back to the flipped classroom. We're gonna do this unit, it's 5 days long, as a flipped classroom. So you guys are gonna watch the videos. We're gonna do some activities in class. We will do some questions together in class, but you will be doing a lot of group work, individual work in class. I like to see you guys work. So welcome back to the flipped classroom. We're going to start off this unit. This unit's all about, we're going to continue using our trig. So we're going to talk about trig equations and identities. So we're going to introduce some identities here. So one of the first identities that we've been talking about for a couple units now, and if you'll see, we have sine, cosine, tangent, cosecant, secant, cotangent. Those are our reciprocals there. And then we also have our quotient identities. So if you want to take a minute just to jog your own memory and write down the ratios for sine, cosine, and tangent, and then write your reciprocals for cosecant, secant, and cotangent. And then we will start back together with our quotient identities. So hopefully you had all of your identities correct. For your reciprocals, we've been using those quite frequently through these last couple units. All right, our quotient identities, another way that we talked about writing the tangent of theta is to say that it was the sine of theta over the cosine of theta. And if cotangent is the reciprocal of tangent, then that's just equivalent to the cosine of theta over the sine of theta. So you'll see as we go through this unit and we simplify, we're going to verify some identities, we're going to solve some equations, you're allowed to replace these different trig functions with different reciprocal identities using the quotient identities, and we're going to talk about multiple other ones which happen to be on your reference sheet, so that makes things convenient. We recently talked about cofunctions, sine, cosine, secant, cosecant, tangent, cotangent. And remember we said that the two of those angles had to add up to 90 degrees. So when you write all of these, and all of these blanks are going to all be the same thing here, these are all just 90 minus whatever your x value is. So basically they are complementary. They have to add up to 90 degrees. So each one of those blanks in there is all going to say 90 minus x. So as long as you know that, you don't need to fill in the rest of the blanks. All right, now for our Pythagorean identities. So if I wanted to plot this point up here as xy, if I started from the origin, I would go over to the right x number of units, and then I would go up y number of units. And this point up here at the top tells us we're in the unit circle, so I know my hypotenuse is 1. So using your Pythagorean theorem, which you all love to use, even when you're not supposed to, your Pythagorean theorem says a squared plus b squared equals c squared. So in this case, it's just the square of the legs. So in this case, we would say x squared plus y squared equals 1 squared, because that's our hypotenuse. Now, when we talk in terms of your trig functions, we said that this point here represents the cosine value and then followed by the sine value. So if we were to replace x with cosine, knowing that our adjacent side of our angle here is your cosine, and the opposite side would be the sine value, we can now say that cosine squared plus sine squared is equal to 1, since 1 squared is just 1 anyways. So this cosine squared plus sine squared equals 1 is your major Pythagorean identity. Now, using this Pythagorean identity, you can manipulate this to make other Pythagorean identities. So one of the things that we can do is we can subtract sine squared. So if you were to subtract sine squared, you would get cosine squared equals 1 minus sine squared. So you're allowed to do that. If I took and subtracted cosine squared, I would get sine squared equals 1 minus cosine squared. Okay, so there's another identity that you can use. The other thing that you can do is you can divide everything by one of your functions. So if I start with my original, cosine squared plus sine squared equals 1, and I decide that I'm going to divide everything by cosine squared. Well, cosine divided by cosine is just going to be 1. Sine squared divided by cosine squared. Remember, sine divided by cosine was tangent. So this is tangent squared. And then 1 over cosine squared. So remember, 1 over cosine is secant. So this is secant squared. So there's another nice little identity for you. All right, let's say we took our original and we divided everything by sine squared. Okay, well, cosine divided by sine, okay, so that's the first one. Cosine squared divided by sine squared, that's going to give you cotangent squared. Sine squared divided by sine squared is 1. And 1 over sine squared is your cosecant squared. So there's another identity. And then again from there, if you subtracted 1, you could say that the tangent squared is equal to secant squared minus 1. So you're allowed to use any of your equation properties, being able to use your inverse operations, and you can rewrite those so that you have all of those different identities. So if you wanted to rewrite these at the bottom, this could be the same as tangent squared equals secant squared minus 1. Cotangent squared is equal to cosecant squared minus 1. So you're allowed to replace, and you'll see as we go through the unit where you can use these different identities in replacing them as you're using them. All right, when you're asked to simplify an expression and all you have is a bunch of trig functions, basically what you're doing is you are substituting in some of your different identities and simplifying it down as far as possible. So for example, secant we could change into 1 over cosine. Tangent squared we could change to sine squared over cosine squared. And secant we can change into 1 over cosine. So basically all I did was I went through and I substituted in different identities. Now this first one here is multiplication. So if I multiply straight across, I'm going to end up with sine squared x over cosine cubed x. Okay, in order for me to add those together, I need a common denominator, so we're going to multiply this one over here by cosine squared over cosine squared. So now in the numerator I have sine squared x plus cosine squared x over the common denominator of cosine cubed x. Now remember we talked about the Pythagorean identity just now? Okay, so this identity right here, sine squared plus cosine squared, that is equal to, whoops, didn't mean to keep my highlighter there. That is equal to 1. So we have 1 over cosine cubed x. So you could leave it like that, or you could also say that's the same as secant cubed x. Either one of those answers would be correct. All right, I'm going to skip down to number 3 here. So we have the cosine of theta. Whenever you can, try and keep things in terms of sine and cosine. Tangent is sine over cosine. And cosecant squared is going to be 1 over sine squared. All right, so now just like we did rational expressions, and when you could reduce common factors, the cosines are going to reduce to 1. Then we multiply straight across, you're going to get sine theta over sine squared theta. And this is going to reduce just like x over x squared would reduce. So you can leave your answer as 1 over the sine of theta, or you can write it as its reciprocal, which would be cosecant of theta. So either one of those would be correct as a simplified form. All right, the last one I'm going to go over here with you for a minute is going to be number 6 before we get into verifying identities. So one of the Pythagorean identities we said was cosine squared was equal to 1 minus sine squared, and we'll get to that in just a minute. But what I want you to take a look at right now is the fact that we have an unlike fractions here. They don't have common denominators. So I'm going to change this 1 over 1 to 1 plus sine x over 1 plus sine x. Because remember, anything divided by itself is just 1. All right, so now we have a common denominator, so now we can add them together. I'll subtract them in this case. So we have 1 plus sine x minus cosine squared x all over 1 plus sine x. All right, now, when we take a look at this, now is where we're going to do our replacing. So that cosine squared, we are going to replace with a 1 minus sine squared x. So I now have 1 plus sine x. Now, I'm subtracting this whole thing because when I replaced cosine squared, it was a negative cosine squared, so I have to distribute that negative to everything. So that's going to be negative 1 plus sine squared x. All right, now I've got to do a little combining of like terms and cleaning this up here. So I have a positive 1 and a negative 1, so those are going to be 0. And now I have sine squared x plus sine x all over 1 plus sine x. All right, if you'll notice in the top you have a GCF there. Your GCF for this one is going to be what? Good, sine x. So I'm going to take out a sine x. I'm going to come back up here. So if I take out a sine x, what am I left with? Good, sine x plus 1. Now, just like factors of x plus 3 and 3 plus x, isn't sine x plus 1 just the same thing as 1 plus sine x? Yeah, so we can just reduce those. So the only thing that we have left there is sine x. So that expression reduces down to sine x. All right, verifying identities. We'll do some more of these practice ones in class, but I just want to give you an idea of what it means to verify. When you verify an identity, you pick one side of your equation and you simplify that side of the equation. So what we just did in the last couple examples, you're only going to do to one side of the equation. Your goal is to make the one side of the equation look like the other. So for example, in number 1, I'm going to take sine x plus, we have cosine x. I'm going to change cotangent into cosine x over sine x. Now, notice I'm not going to touch the cosecant for right now. This is what I want my expression to look like when I get all done. All right, these have denominators of 1 here, so I'm going to multiply these two together. So we have sine x over 1 plus cosine squared x over sine x. Now, if you'll notice, we have two fractions here. They have different denominators, so let's give them a common denominator. So I'm going to multiply by sine x over sine x. Now, what that does here is that gives us a sine squared x, plus we have cosine squared x. I now have a common denominator of sine x. Now, if you remember at the beginning of the notes, I said sine squared plus cosine squared was equal to what? Yes, 1. So right there's that Pythagorean identity that comes in handy. So this is equal to 1 over sine x. Now, what is 1 over sine x? It's cosecant. So because it's cosecant, and then we wanted cosecant when we got all done, we have verified our identity. That's your goal right there, folks. Simplify one side of the equation so that it looks like the other in the end. Okay, so it's just a process of simplifying, except you know where you have to end up at the end. All right, that's all I'm going to do for the verifying. We'll do some more in class. It's really just a practice of getting used to knowing your identities, what you can substitute in. Sometimes it takes a little guess and check. Hey, if I go this route, is that going to make something simplify? If not, maybe I got to try a different route. So we'll do some more work in class. So make sure you have your homework packet with you in class. And I hope you guys enjoy your nice long weekend. Or I hope you have enjoyed your nice long weekend for those of you that waited until Monday night in order to watch this video. Have a great weekend, guys. See you in class.